Hi, everyone. My name is Shelley Lambert, and we'll get started on this presentation about Java performance testing for everyone. And what does that actually mean? Who is everyone? I write this, or I'm thinking about this from the perspective that I am one of the people I want to create tools for and be able to solve this problem of performance testing for. So people who don't have time to become performance analysis experts, but want some assurances that if they have pushed code into a repo, that they haven't regressed horribly. So just to give you a little bit of a introduction to me, if you haven't met me yet or heard me talk about myself at length. I'm an AdoptOpenJDK committer. I'm an Eclipse OpenJ9 committer, and I'm the IBM Runtime Technologies test lead. And what does this really mean? It just means we do a lot of testing. And performance testing is one of the things we do. And one of our main focuses over the last year is how do we make testing easier for everyone? And a particular problem space is performance testing. It's probably one of the most challenging types of testing that we do, and it's one of the places where I think we can bring the most value if we have some tools that make it easier for developers and for others. So again, that's so coming out fairly strangely, but just to give you a perspective, I'm a development manager as well, so some testers and some GC team members report to me, but I do still actively help out and write code. I'm also a yoga teacher and a food forester, so if you have like aches and pains and you want to do some stretching after, come find me after the talk. I'd be happy to talk about any of that. And that's me holding a giant maitake mushroom from a food forest that I have in Ottawa, Canada. Can people see that all right? Yeah, great. So just to give the scope of the work that we do, we have testing across two Eclipse projects, Eclipse OMR and Eclipse OpenJ9, and a lot of testing that we're bringing to the AdoptOpenJDK project as well. This means we're actually running or monitoring tests across more than 6 Jenkins servers. We test on more than 18 platforms at any given time. We test more than 6 versions of Java, and you say, what is that? Are there more than 6 versions of? Yes, there are. We actually test more than 4 implementations, and what I mean by implementation is hotspot implementation, of course the OpenJ9 implementation, there's even an SAP implementation, and a few variants of all of those. And then in the test categories, I'm going to go in a brief detail about the different kinds of tests before we talk solely about performance testing. But when you add it all up and you actually look at how many tests are running nightly around the world, it's pretty impressive, and pretty challenging as well. But let's get right into some of where to start with performance. When you think about the story of Java performance, I think the old joke in the early days of the language was, if someone said, how do I write code that is faster? The ha-ha-ha joke was use a different language. But of course, in our modern era, JVMs are actually very sophisticated. GCs and JITs underneath the JIT code actually allow us to write fairly sloppy application code and still be fairly performant. So I guess the thing to say is there's no single recipe. When someone asked me, can you give me some tips on how to write more performant Java code, it totally depends on a lot of different things, on the implementation, on the hardware, on how you've laid things out. So instead of thinking about, this talk does not give tips on how to write more performant Java applications. There's a lot of people that you can talk to after that will give you opinions. But what we're going to talk about is what do we need to do to simplify the task of testing performance. Often people say JVM's very complex, intricate, subtle. You often hear the story of it's, not going to be easy. It might be impossible. It would be great if it would be simple, right? You could just add an extra command line option that would say, go faster or use less resources, depending on how you want to be performant, because of course there are metrics that you want to be good at, and depending on where you're running your Java application, you might want to slide across the scale from being less fast to using less resources, and as you go and move along that scale, it actually kind of changes. You take from one side and slide it to the other. And I do want to talk about the personalities that are involved in undertaking this work. It's the personalities that like to live in that intersection. When I hear that something is needed and necessary, so GC developers come to me and say, we need to be able to more easily test this stuff. They have a lot of scripts on their desktops. They have a lot of techniques that they're using, but they maybe don't share them all the time, or they, it's something that we could take advantage of that we don't know about. The other end of it is you have developers that say it's impossible, it'll be too hard. If you don't have an isolated test machine, it can't be done, we can't prove anything. Somewhere there's actually an overlap between necessary and impossible, and that's the area we're going to try to land in for some of this. So let's first say, what is performance testing? Yes, you could call it an experimental science, some people have, but actually what it is testing if a system accomplishes its designated functions within given constraints. So, and we could be talking about processing time or throughput rate. In fact, I'm going to show a set of metrics that probably people care about, and the set of metrics that we started with to make the story simple. So it could be speed, it could be resources, it could be a blend. There's a lot of different things that different people care about. Instead of trying to boil the ocean, we decided we would take a look at just a couple of things, because if you properly measure a couple of the metrics, you can actually get to some of the other metrics. They're derived from some of these measurements. So can we measure throughput, and can we measure utilization? We can keep it simple for the first bit. And I'm talking about measuring this in the context of open performance testing. So obviously we have a lot of different things that we're doing inside IBM. My mission was to try to bring some of this out to the open projects and start innovating how we test performance so that more people could benefit and so that more people could be involved. Essentially, how it was working internally was developers would add some changes and then queue up in a line to ask a performance measurement team to be able to run some testing for them, compare against a baseline, go back, make more changes, wait in a line for someone to do some testing for them again for some of the larger benchmark suites. This obviously is not an agile approach, and it also wasn't helping to elevate the level of knowledge across the team. So what we wanted to do is figure out how we could share some of this across the team. But let's go to what are the basic steps. I just kind of mentioned them, but you set a goal. You decide what metric are you going to try to improve. I'm a developer. I want to improve metric A. I measure it, and I have a set of tools. Someone told me how to run this benchmark suite, so I'm going to run it. I adjust. I apply some experiments to my code. I measure again. how exhaustive do I need to be with my measurements so that I know that I can trust my results? And there are techniques, obviously, that we can use to say, if I'm not on an isolated lab machine, how do I know if something else didn't interrupt or kind of munge around with some of my test results? So you can increase the number of times you run something to take the average, and you can kind of become more confident in them. But there are other things that can be done as well. Anyway, the final of the basic steps is you verify your goal. Did your metrics improve? Did they improve enough? And then you go and repeat these steps again as you continue on in your development. So just also as a note, these are the different categories of testing that we do in the open. This is also a set that we run, or some of these we run at the OpenJ9 project as well. But a quick overview of these again, if you haven't seen them. The functional and OpenJDK suites, those are essentially suites that are testing functionality. You can think of them as regression tests, unit tests, functional tests. These are tests that test a particular piece of functionality in a JVM, and the underlying frameworks vary depending on where we've pulled these test materials from. Then we have the system tests. This is another type of performance test, in fact, because system tests in this category include a lot of load and stress tests. So they are able to kind of bring a JVM to its knees if there's something wrong with the JVM. We want to be able to break things with this testing and come to the edge of breaking things and see how a JVM performs. But in the context of the rest of the talk, I'm not going to spend too long on the system tests. External tests, these are actually application tests that we've pulled. So Scala, OpenLiberty, a lot of different applications that we take and run their functional suites, but we also run some micro-profile TCKs here. And then there are the compliance tests, and finally the perf tests. So I'm going to drill down into that last box to look at the perf tests. And we've broken them out into two categories. So the large-scale benchmarks and micro-benchmarks. And this is what we intend to grow at AdoptOpenJDK. Right now we only have one large-scale benchmark there, but shortly we'll be bringing Acme Air and Liberty Day Trader benchmarks there. And we also have an idle micro benchmark running in the nightly builds, and shortly we'll be bringing a bunch of Bumblebench micro benchmarks. So those ones are in different categories, like micro benchmarks for string implementations and different things like that, shared classes and that kind of thing. So that's kind of the view of it. We also have brought to that project a set of tools. So one of the things we wanted to do was make it easy to run benchmarks and tune them. Every one of those benchmarks on that last slide has a different way of being able to run them, and different sets of options that you can change and tweak and tune, and they all mean different things. And one of the things we noted was no one wanted to learn 20 different benchmarks and how to become an expert in running them. So could we create a tool that would make it easy to configure, tune, and launch them? And so we did. And we're calling it, at the moment, calling it PerfNext. And if you look in that repo, you'll see some code for that. We also have a results summary service there in a folder in that repo. And the intent of that is to be able to visualize the performance results. And I'll try to show you a live running of that shortly. If that doesn't work, I'll also just show you screenshots. I have to get through a firewall at the moment to be able to show you a live running version. We will be running this tool live in the open and monitoring nightly benchmark runs at AdoptOpenJDK. So even if you yourself never want to run a benchmark or be able to clone these repos and run them in your own lab, you'll be able to go and see and compare results across the different Java versions and implementations that we'll be running them against. This is also the repo where we're going to be doing some fun experiments with some analytics tools as well. So once we start gathering a lot of data, we want to be able to take a look at it in interesting ways. So that's where this will come in. All right, so this is my screen capture thing. I'm actually going to try to just show you, maybe or maybe not, yeah. Slide that over. Is that happening? No. You're over there? I actually don't have a good view of that, but let me see if I can get. Not helpful. Well, I may just go back to this just to not. You can come find me after. I don't want to get too lost in my presentation. I'll go back here and then you can come up and we can step through the actual live thing. So what I wanted to say anyway is that for the benchmark launcher, I personally don't want to use the GUI for launching benchmarks. I actually rather launch them from the command line, which we're able to do quite easily as well. But for the performance measurement team, they wanted to be able to get in at it and use it through this tool. So they helped create this tool to make it easy to pick the version of Java that you wanted to use, pick the benchmark, and when you select the benchmark, it then brings up the options that you can change. And by default, it fills out a bunch of the options. The default settings are the ones we use for the nightly runs, but they have a hover over that you can learn about, if you change this, what it means. The other interesting thing here is it lets you select, so this is actually contacting a Jenkins server and lets you select nodes that have been tagged or have a label that say this machine can be used for performance testing. And what it does is it actually goes and asks the machine about itself to make sure that it can give you the information about some of the underlying aspects of the machine, so that you will know that some of these options won't be available for tuning or changing because the machine you're about to run on won't allow it. And then at the end of selecting your options, you pick launch or run benchmark from that GUI, and it actually sends the job to a Jenkins server, any Jenkins server in fact. We're able to, with the tools we have, connect to any one of the 6+ Jenkins servers that we have running in the build. There's no reason why anyone couldn't go get the tool and connect it to have a local instance running and connect it to their own Jenkins server, in fact. But this will help us track the progress of the benchmark runs and verify their output. So we have that view, but what if I also want a little bit of help understanding the results of the actual benchmark? Well, in the results summary service, we have comparison view, and you can think of this as kind of an executive summary. So depending on what benchmark you launched, we grab the results and make a little summary for a person to be able to see what just happened and what numbers do I care about, coded in green and red to quickly know if something looks good or bad and if you need to pay attention to it. And actually, why did this even get created? Because the performance measurement team was actually using a spreadsheet and creating a summary for other people. And so we just pulled out of their heads what they had to do and created a tool to help them be able to do it quickly. And we found that it's quite useful. The other view we have in that tool are graphical view, and you can of course look at that days run, the full month, all the data. How it works, actually, it's Node.js in a React framework, and then it's shoving a bunch of data into MongoDB. And when you hover over the graph, it will tell you about what Jenkins builds it pulled data from, because in some cases, each point on a graph could be 2, 3, 5, 10 runs, and it's the average, and in other cases not. So it has become quite useful for the team to be able to get quickly to what is that dip in the bottom of that final graph. That would be an interesting thing to go explore. And the other thing that was open sourced recently as well is Bumblebench. So micro benchmarks typically aren't the easiest thing to write or to write well. Bumblebench is actually a tool that had been used a lot by the JIT compiler team in Toronto, and it has some features that make it really easy to write a benchmark and then very easy to run a benchmark. So I invite you to go check out that repo and that tool. So that's all of the micro benchmarks that currently live in that repo will be run nightly. Once I get away from this podium and check in a pull request that's open. But I guess the other thing I wanted to say is that from the perspective of writing micro benchmarks, this is often left to the developer who is writing or making changes to the source code. So if we are able to actually take away the friction of the tools that a developer is using to get to the point of being able to write the suite or the benchmark quickly, you get a lot of side effect benefits from that. So one, you're not frustrating a lot of people. Two, you can get back to the actual real work of making feature changes. And three, you make it really easy to maintain these things and onboard other people. So when someone goes and sees this benchmark, they can quickly understand what's happening and pass along some of this knowledge to the rest of the team. So I think we've started being able to do a lot more of that lately. And I do want to mention that that is one of the reasons I really love working in the open. Some of this stuff that we've had to figure out how to share makes it a lot easier for us to collaborate with other teams outside of our own. And I've talked to a few of you at this conference, and I'm really looking forward to working with more people across the globe on some of this stuff. So I guess the takeaway here is that if you have particular needs, if you want to look at different results and that kind of thing, you should just get active in any one of these communities and start asking, is this possible now? Or is this something that could be created? Because typically a lot of people have an interest in it. So I'm going to actually get right into a conclusion, so I'm going to try to stop a little bit early so that people can come up and we can have a discussion if you have questions. But the conclusion of all of this, what I've learned from all of this in the last few months, is that yes, perf is hard, but it's not impossible. We actually have a lot of requirements from both the JIT team and the GC team that I didn't think I would be able to understand or meet when we first started doing some of this work. It's still a work in progress, obviously, but it's something that I've realized isn't so hard. It's one of those things in life where you actually learn, the first reaction is always to say, no, sorry, it's too hard, we can't do it. But once you actually dig into it, you realize that if you take little bites of the sandwich, you'll eventually finish eating the sandwich. Is that not the elephant from yesterday? But micro-benchmarks as well. So the impossible thing was people telling you, oh, it's really difficult to write, so we won't write any. Well, how about we make it a little easier to write them, and then we can write them and start to notice early on when we've regressed. So micro-benchmarks typically are a thing that very quick to run, very easy to run, and you can do it right on your desktop. So you don't even have to run through all the giant mechanisms of these open source tools and pull request testing before you can do a quick litmus test for yourself as a developer, as someone who doesn't want to cost the whole team time on the Jenkins server when you could do a little check for yourself before you even get that pull request together. And data is noisy. This is another kind of excuse you often hear. Well, there's no point running any perf testing because it's too noisy. And once we do run it, it's subject to interpretation, so why bother? Again, when I hear those kind of excuses, I go, ah. It's not enough to just say that and call it quits or raise the white flag. I think in that case we apply some of the techniques that we know to make for a better result. A very recent example of this was actually in the GC team. If you go to the OpenJ9 repo, we're having kind of fun being able to experiment with some changes to the garbage collector to see if they'll actually help us eke out that extra little bit of performance. And one of the developers who actually helped work on the perfnext thing is now in the GC team, and he's laying out graphs and laying out strategies for how do we remove all of this uncertainty from these results. And for a GC developer, one of the ways you do that is you turn off the JIT. But what if you don't want to turn the JIT off? What other techniques can we use? So in the OpenJ9 JVM, one of the things you can do is actually preload, use shared classes to be able to pre-compile some of the stuff that you need, and then that takes away the uncertainty of some of the JIT compilation. So we found that we could take the data noise that was giving us this 7% uncertainty and reduce it down to 1.5%, which makes us much more confident in those results. So I guess the point is of this whole thing is don't easily say, oh, I give up. Think about really what are the solutions that you can come up with. And then finally, let's build some tools to make it easier. And I've showed you some of the repos where some of those live, and at that website where a live version of this will be living shortly. So you should be able to start going there once we get the web server up and running, and be able to see of those JDK binaries that are produced at AdoptOpenJDK, how are they doing when it comes to in terms of performance, and actually be able to look and compare. All right, so, and I guess the final note here is open collaboration to me means greater innovation. So the more people are thinking about how to solve these, the better. And I hope to collaborate with all of you, and that's how you can kind of get a hold of me. So if people have questions, if people want to come up and see an actual live version of this machine running, come on and talk to me. That's all I had to say about that topic today. Do people have questions? No.